Problem number 16. A bead attached to a string of length L equal 10 meters is released from a very small angle θ0 to the vertical. A wall is placed in the path of the bead such that the bead collides elastically with the wall when the string is at an angle θ0/2 to the vertical as shown. What is the interval between the bead's collision with the wall? Solution for problem number 16. The angular frequency for this construction will be omega equal square root from g/L, which is 1 Hertz. For that frequency we have a period equal 2 pi over omega or 2 pi seconds. Equation for this motion is omega equal omega 0 multiplied by cosine omega t. The moments when the bead reached the wall in position when cosine equal negative 1/2 are t1 and t2. So we need to exclude from this oscillation time from t1 to t2, and total time between collisions will be period minus t2 minus t1, which is 4 pi over 3. That's answer C, and that was solution for problem number 16. Problem number 17. 3 physical pendulums are built as shown. The first is a typical pendulum with a massless rope, and the second and third are made of uniform rods. What is the correct ranking of the moments of inertia I1, I2 and I3 about the pivot points? Solution for problem number 17. This is a straightforward application of the standard moment of inertia formulas. So for the first pendulum we have I1 equal ml square. For the second pendulum we have 1/3 ml square, and for the third pendulum we have 4/3 ml square. So from here we have this relation, and the correct answer is E, which is solution for problem number 17. Problem 18. Alice, Bob and Carol are each given identical airtight bags containing identical rocks and a large tube of water with a scale sitting on the bottom. Each of them measures the weight of their bag and the rock by putting the bag on the scale, using 3 slightly different procedures. Alice closes the bag carefully so that there is no air inside. Bob fills the rest of the bag with water before closing it. Carol closes the bag loosely so that it contains some air. What is the correct ranking of their measured weights, WA, WB and WC? Solution for problem number 18. The scale's measurement is the weight of the object not supported by the buoyant force. In other words, the scale measures mg minus rho vg, where m is the mass of the bag with rocks, rho is the density of water, and v is the volume of replaced water. For Alice we have this measurement. If Bob adds a volume delta V of water, he adds a mass rho delta V as well. And practically we have the same measurement for him. Carol adds a volume of delta V while adding a negligible mass from the air. So we have the same but weight of replaced water by additional volume of air. Therefore the answer is E, And that was a solution for problem number 18. Problem number 19. A student sets up a simple pendulum, measures its length to be L equal 0.50 plus minus 0.01 meters, and observes a period of oscillation of t equal 1.4 plus minus 0.1 seconds. Using this data, the students computes g equal 10.1 meters per second square. What is the uncertainty of this measurement? Solution for problem number 19. From formula for mathematical pendulum, we have g equal this expression, and we can use the standard rules for propagation of relative uncertainties. The relative uncertainty of a product or ratio of two quantities adds in quadrature, and the relative uncertainty of a squared quantity is doubled. From this we can use this formula, delta g over g equal this expression. Thus we have delta g equal 1.4 meters per second square, and that's answer C, and that was a solution for problem number 19. Problem number 20. A mass attached to the end of a string oscillates like a pendulum with a small amplitude. The mass has a horizontal velocity Vx and a vertical velocity Vy as functions of time. Which of the following could be a graph of the curve Vx and Vy over a complete oscillation? Solution for problem number 20. The answer is choice C, because it could be shown by plotting several points. For example, one simple way to rule out the other answers is to note that on a pendulum, Vy hits 0 4 times per cycle. When it reached the maximum displacement, vertical speed is 0, and when it hits the equilibrium position, that would be twice. Again, vertical speed is 0. So that's the answer C for question number 20. And that was solution for problem number 20.